Hello, we're going to talk to you about BotNet, a simulator for studying the effects of accurate communication models on multi-agent and swarm control. Communication in multi-agent robotics is crucial in the domain of decentralized control, where neighbors must rely on information from each other in order to make decisions. A first important aspect of communications models for control is the scheduling function. A scheduling function controls who will communicate when and who will receive. This is especially important in multi-hop networks where edge agents need to communicate with the central node. Additionally, we study the effects of different propagations models, which is to say, who can communicate with who in a given environment. There are many different models that are used. Some, like line of sight, look to see which agents are in a field of view of another. But in reality, there is an experimentally random model that has been measured with real-world deployments of wireless sensors. BotNet is composed of two parts. It is a multi-robot physical simulation built next to an RF mesh network simulation to study how these two aspects interact. Here is a brief example that we will return to of line formation. Here you can see, because communications is not ideal, the line formation breaks into subcomponents. Here we are showing you a visualizer for a 6-dish wireless network. 6-dish combines modern internet protocols with a low-power solution that can be scalable to many agents, so it is a compelling solution for low-cost and swarm robotics. With the communication side is the Swarm Sim Dynamics Simulator, which is a lightweight and extendable framework for multi-agent dynamics. Now we will show you our simulator in work. What happens is, you load a scenario, and then on the left side you will see the network visualizer. So the network will start building the communication links between the agents. And once the network has initialized, which is actually an open problem of study in wireless sensor networks, we can then go and start the simulation of dynamics. Here you can see an example flocking task where the 7 agents must follow this one leader agent while communicating only with their neighbors. Now we will show a series of experiments where we compare formation control tasks with and without ideal communications. These algorithms are all fully decentralized, so the failure modes that you see are due to neighbors failing to communicate with each other and then lacking the central information to reestablish their correct position. In conclusion, we hope you see the promise in the simulator we have created in BotNet. It is a new lightweight tool that provides incredible access to studying the nuanced effects that accurate communications models will have on swarm and multi-agent control.